will we do the trigonometry practical problems? How did they go for you? Were they okay, or what? Your book is a little bit different though for the practical problems. Can I see what you have? Who the heck is calling me? Only my father. Right. Yeah, oh no, yeah, let's see. Yeah, okay, it looks nearly the same. There might be tiny differences between this one and the one online, but no, it looks like you have the more recent one. I think actually this one I changed. Yeah. Numbers, yeah. I felt it would be more appropriate. Okay. Will we do the log one first?
You can do the ones, because I still don't have the questions. So
right. Will we do the trigonometry then? The trigonometry sine and cos rule. Okay, so we'll start with the first one then. Actually, you know what? I probably should open them because there's a picture. No, sorry, maths part 1. I didn't do any of these in class. I did questions that are similar to some of these in class. So we'll do a couple until this guy finds a log question. Hey, you're quite late.
Yeah, he was at the bank.
I was.
Yeah, he was.
Yeah, and what about you? Helping him at the bank?
No.
Holding his hand? There.
No.
It'll be okay.
It's not like that. It's not like that.
Please don't break anything.
Oh.
Wait, why are you late, Faisal?
Yeah, he was at the bank.
Why are you late?
Trick question.
Not really a trick question.
Yeah, see, there was some complications on the way.
Yeah.
On the way? Yeah, I didn't want him to be the only one late. So I was like, I support you. We're still not 10 minutes late, so it's fine.
Why are you late? Yeah, but why? You had plenty of time.
Yeah, we had 1 hour break, so he ran to the bank.
Why are you late?
Because they didn't take the stairs, that's why.
Why are you late?
Waiting for.
Okay, next week. Hey, next week if you're coming in this late, I'm not going to let you in. It's too disruptive. I'm reasonable. I understand being a few minutes late. We're all busy people, but 10 minutes, 11 minutes, we're pushing the bounds of being reasonable here. It's because it's a small classroom. It's very disruptive to have people coming in.
You can't to the bank again.
You can't. If it was a big classroom, you could quietly come in and sit at the back. But in a classroom like this, you have to cross the room and distract everyone. Exactly. Right. How was number 1 here? I want to do number 2, but do people need to see number 1? Yeah. Guys, if you're not doing these at home, you're going to be disappointed when you have your exam. How was number 1? It was alright? Does that mean you need me to do it or not? Because I think number 2 is harder. Yeah? It's okay? Well, let's have a look. The Earth revolves around the Sun. It is known that the radius is about 150, what's that, billion, is it? That's billion, yeah. So, here is the Sun here. And the Earth revolves around it. So here's the Earth here. And here's the Earth here. And this is, I'll just write 150. And I'll just write BKM. Or is it meters? I'll just write 150 BM. BM, huh? W? Why W? Okay. Billion meters. On January 1st, the student observed something strange in the night sky, which makes an angle of 70, as shown with the Earth's surface. Then 6 months later, the same student notes an angle of 80. Assuming the strange object is not moving, then how far away is it from the sun? So this one is a 70 and the other one's an 80. So there's something strange here. No. Somewhere 70, 80 is the steeper one. So here, yeah. So we don't know how far away it is. This is 70 degrees and this is 80 degrees. This is a typical real life problem. It's very, very easy. What's that? No. It's very, very easy to point at something in the sky and measure the angle. Very easy. Point, measure. So effectively that's what the student is doing here. Also, we'll see in physics how to do this. It's not too difficult to calculate the radius of the Earth's orbit around the Sun. So you also know that it takes 1 year to travel around the Sun. So if you make an observation on January 1st, the 1st of the 1st, and then if you make another observation in the middle of the year, like the 1st of July, I think will be the middle, then you know that the distance between the two observations is 300. The start of July is the middle of the year. July 1st, I think, roughly. So you know that the distance between your two observations are 300 billion meters. This is enough to work out how far away your object is from the sun. This is what we want. Okay. If it's stationary, yes. But even if it's not stationary, even if this was
around the sun.
How far is it to Earth line, AB line?
In the new version, it is not.
Okay.
Yeah. So I made this one slightly harder in the new version because I thought that one was too easy. Yeah. Okay. So what we can do first, we could work out this angle with not too much trouble. This has to be 30 to make 180. We know this distance, so we could use a sine rule or a cos rule to get these two distances here. Let's use the sine rule. I'll call this x and I'll call this y. So we can say x over sine 80 equals 300 over sine 30. So yeah, so can someone just give me this please while I'm opening the calculator? Give me the x. And then likewise we can say y over sine 70 equals 300 over sine 30. So then y equals, what's the x? 591. Give me one decimal place. 509. And then the y, please. Okay, so this is 563.8 billion meters, and this one here is 590.9 billion meters, and we're looking to get this distance here, which we'll call Z now. So I suppose if we look at this triangle, let's see what we have. We have a side, and we have a side, and we have the angle in between the sides. Excellent. So this requires the cosine rule. So we can say now that z squared equals 590. So actually I didn't need this one here. 590.9 squared plus 150 squared minus twice 590.9 150 cos 70 degrees. So turns out I didn't actually need to use these two here, but it's good to put them in. Yep. So what do we get for the Z then? Do I have my calculator open yet? I don't. Do you have a Z there, Juan?
557.
So you get the answer is, what is it?
557.
So three significant figures be 558 billion meters. Billion isn't a proper prefix, but we haven't done prefixes in class. So in the exam, you'd probably want to write it like this: 558 times 10 to the 9 meters then. Physics students, you're welcome to use the prefix for billion, which is...
No.
Deca? What the heck is deca? We've never done this one in physics. That's a chemistry prefix.
Giga.
Don't know.
Giga. Giga. Okay. Okay, so this one's a little bit different to the book version then. Okay. Continue. Did you ever find that log question?
Yeah.
Okay, later. Next. Right, let's see what number 3 is like. Number 3, I did one like this in class, and number 4. I only want to do ones that are different. Like number 5 here, I think. Yeah, number 5 is interesting one. I don't know how many people got it. Number 5, I said to do it in the class. So, did many people get this, or did anybody get this? Did anybody get 5?
Yeah.
Some people got it? Good, yeah. Let's have a look at it. I'll just try and draw this first. So we have the Earth, and then on the top we have a mountain. So here to here, this is H and this is R, and then here to here is how far he can see. So while he's on the mountain, he is looking straight to the horizon. We know the mountain's height is 321 meters, and we also know the angle he needs to look down is 0.567. So if we kind of picture him, if he looks out, he won't see the horizon. He has to look down a little bit. So this angle here is 0.567 degrees. So I'll just draw that a bit neater, maybe in this color. So that angle there is 0.567 degrees. Okay. If we know this angle, can we know this angle?
Yes.
Yeah, it's 90 minus this.
5/2.
Pi over 2?
Yes, isn't that radian?
No, this is degree because it has the degree symbol.
Oh.
Yeah. So if we know this angle, we can know this angle. And if this is 90, then we can know this angle. So this angle here will be 90 degrees minus this angle. And this angle is 90 degrees minus this angle. Yeah, but after we put in the minus the 90s, it turns out that this will just be the same angle. Okay? Yeah. I think a simple cos would actually work just fine here, because you could say cos 0.567 is adjacent over hypotenuse. So we can say R plus 321 cos 0.567 equals or. So we get cos 0.567 or plus 321 times cos 0.567 equals or. So I'll just write it down, or let me just remove this here. So just rearranging this a little bit, we can get cos 0.567 or minus or. No, I'll take things to the right, be a bit neater. 321 cos 0.567 equals or minus cos 0.567 or. There's an or in common to both, so that's 1 minus cos 0.567, 321 cos 0.567. So finally I get or equals 321 cos 0.567 over 1 minus cos 0.567. Huh?
It was why you changed the alpha.
That would be a small earth.
What?
That would be a small earth
Oh.
if the or is 321. Cos 0.567 over 1 minus cos 0.567. So let me just put that in kilometers. 6,555 kilometers. Okay. That's the radius of the Earth. So like I said, this is something you learned how to do in class. You just need to take two angles up to the mountain and the distance between the angles measurements. So you could do that quite easily, and climb to the top of the mountain and looking down and measuring this angle is quite easy to do. So maths. Okay.
Okay, but why you changed the R to minus 1?
Where? Here? Here to here. I took the or out. Factor out the or. I took the or out.
And you got minus 1?
I took the or out from here
Yeah.
and here. It's common. I took it out. Okay. I don't know how many people got that one in class. If you didn't get it, you should write it down now. I wonder what the actual radius is of the Earth. I think his error was less than 1%, or maybe 1%.
Let's find out.
Well, I don't know if these are real numbers. I just might have made these numbers up so the answer would work out nice. It is, yeah, it is 6,000 and something.
Oh.
What's the radius of the Earth?
6,300.
6,300?
71.
It's not bad.
Yeah. The moon is small and cute. Wait, oh. The sun is 695.7 kilometers.
Kilometers.
That's what's written KKM.
They didn't write KKM.
It's written KKM.
What website's that?
Google.
KKM?
And Mars is KKM as well.
That makes me sick.
But like capital K stuck to the number and then kilometers. It is kilometers.
No likey. No likey.
Okay, wait, I'm googling KKM.
No, Tom, please leave me alone. Right.
Can we use that in
KKM?
KK bro.
Don't use KKM. KKM is mega M.
Yeah.
Okay. Did you write that down if you need to? Yeah, it's okay. You have that? Did you write it down? Right.
I won't have time.
1, 2, 3, 4, 5, 6 lines. If you weren't talking to Lee, you'd be half finished now.
Because I almost
And if you stop talking to me and start writing, you'd be half finished.
Okay, I googled KKM.
Yeah?
Commentarian Kesihatan Malaysia.
Is that some political group in Malaysia?
I have no idea. And then there's Kio Karamao, there's companies. There's not kilometers.
Shame. Sadly, yes. Okay, what else is after that one?
I have questions from different.
That's fine, we're going to have a... Did you find that log one? What lesson is it on?
The practical problems one. For log.
Log.
Minus
Which one?
9.
What's 9 about? This is the chemistry one?
Yeah.
Okay. We'll do that one.
Mine is on trigonometry. So do this one then.
You have one more trigonometry one. Yeah, which one?
Question 3A from the
Too far.
trigonometric equations.
Oh, trigonometric equations. Maybe before this. Which one?
3A.
3A.
Yep. I got half of the answers right.
I will do it as the very last question today, because this is a super low priority, since these questions are not on the exam.
But it's for my
To grow as a person, yes, exactly. No, I understand.
perception.
And this is why it has the lowest priority right now. Yeah. Yes.
For you.
Thank you. Thank you. Thank you. I will do that, but I must prioritise the topics which are actually on the exam first, which is the log questions then. This question was on the older syllabus, but then 1 year ago they changed it so that these types of quadratic trigonometry equations are not on the current syllabus, which is good news for you, but I do appreciate for a sense of self-satisfaction that you want to see it done. Yep. But you appreciate the priorities I put in place. So let's have a look at that log question then. Can you read it out there?
In chemistry, the pH level of a substance is defined as minus log base 10 H plus, where H plus is the concentration of positive hydrogen ions in units of moles per liter in that substance. If HCl equals H plus equals...
Well, what's that? If HCl
equals H plus equals 0.1, then what is the pH level of HCl?
This bracket means concentration.
Yeah, no, we'll calculate it. So the pH level of HCl would be minus log base 10. I don't even know if I'm writing this right because it's chemistry and I was pretending to know about chemistry and make a chemistry math question. So I apologise now if this is totally wrong chemistry wise.
So far good.
So far good. This is equal to, you could change this into log base 10, 0.1 minus 1, which is log base 10, 10, which is 1 then. That's okay so far?
Yeah.
Okay, part B.
If 2H2SO4 equals...
2?
Yeah, H2SO4.
H2SO4, like this?
Yeah.
Yeah.
Equals H plus equals 0.1.
Yeah. What's the concentration? Yeah. So the pH level will be minus log base 10 of the H2SO4, which is minus log base 10, a half of the H plus, which is minus log base 10, 0.05, which is log base 10. Now 0.05 is 1 over 20, and minus in the front makes a minus here. So it's log base 10 of 20, which I cannot do. It's going to be a decimal. So 10 to what power makes 20? It should be a small number slightly greater than 1, so I'm going to go with 1.2.
Use exponential.
No, you can use the log base here on the calculator. 1.3. Okay, you might need to write this part down. It's a little harder than the previous part.
Yeah, but why did you use the half?
Because
It's a quarter. No, I don't even understand why it's half. It's a quarter.
No.
This is-
It's a half.
Hang on. He doesn't speak much, but when he does, he's usually right. So I want to hear what he has to say. Go on, Lee.
Because you want to calculate the pH, it's
Write it in the dictionary.
No, must practice English. I don't know what that is.
Use the dictionary.
What's the answer at the back?
concentration.
Yeah.
You want to calculate you need the concentration of hydrogen.
Oh, now I understand. Thank you.
No, from the
It doesn't matter. I'll just redo it. Thank you. So wait, no, I forgot. There's 2 here and 2 here is what you're saying. Yeah. Mm.
But that's the H ions.
Yeah.
Yeah.
Do you know how to do it? Yeah.
Try a quarter if I get the answer at the back.
Yeah.
At some point in time you knew the way to do it and you wrote the answer down.
Yeah. I was probably looking up at Google, Yahoo, or Yahoo Answers page or something. Huh?
Yeah.
Let's have a look. If this came up in the exam, they would absolutely have to explain how to calculate it, because this is requiring chemistry knowledge, which I clearly do not have anymore.
But why do you still use 1/4, not 4?
No, I was using 1/2 previously.
Yeah. Why did you use 1/2, not 2?
Is this the answer at the back?
Go back to the calculator.
What?
Why is it okay, yeah.
What is it at the back?
0.699.
Ah.
So use the 2. You should use the 2.
What's the answer?
0.69.
0.6.
Hmm.
If you just take one.
Yes.
Ah. Okay.
That's why I wanted to ask.
The answer's wrong. For this one? See, I tried to make a chemistry question and I failed. So now I'm thinking to just delete this question or to change it to make it clearer.
Could there be a similar one to this one on the exam?
I think there's another question in the paper here. What page is this? What page is that? 54. In the exam, I've only ever seen 9A, not 9B. But I want to figure out this now. So my answer's wrong. Yes. So everybody here's a chemistry student.
Yes.
Right. So can you tell me how to fix the question then? Just fix the answer. So how do I calculate it then? Was I right the first time? Or I was wrong the first time? pH equals... Go. It's the same because I said this. Yeah, because I said this. But I didn't mean that. I wanted the answer to be 0.69. So what would I need to do to change it to fix it? Do you understand what I mean?
You need to change the concentration of H2SO4 into 0.1. So you will make the concentration of 8 plus is 0.2. So the pH will be 0.699.
I don't know. What's this POH? That's pH level?
That's the opposite of pH.
Ah. This is pH. See, I was thinking...
You just have to delete the number 2 in front of the concentration of H2SO.
Delete this?
Yes.
But I want the answer to be 0.69.
Yes, that will make the answer to be...
It will?
Yes.
If I write this equals this equals this?
No, not H plus, you need to...
Oh wait, I understand. If I delete this,
yes.
I make this equal this.
Yes.
Ah, there's two of them here.
Yes.
Ah, okay. Now we're talking. Alright, good. Okay, that's what I meant in the question then. So...
I wasted a lot of time thinking about this. And then it turns out the question itself is...
But don't you feel like you grew as a person trying to understand this? No, you had to look deep inside you and, discover the truth. Okay, that's what I meant in the question then. Yeah. So I need to delete this and the 2.
Maybe it's a quarter H2S.
I think we're moving away from the quarter though.
No, concentration
Yeah.
is the coefficient times the number.
Yeah.
Yeah, like
Coefficient times the number of hydrogens.
coefficient and the
I have a great
H2.
idea.
Yeah, and
Delete question 9.
yeah.
Problem solved.
It is a good idea.
Because even in chemistry,
That is also a good idea. You do? Let me just see what the pH level is.
Number of H plus ions, concentration of H plus ions.
I get to that too. .01. Oh, Yahoo Answers. This is what I was looking at then. H2SO4 is H plus H2SO4 with a minus. So it means that for every one of these there must be two of these to make it neutral, isn't it?
No.
No?
For everyone.
For every one of these?
There is one of
There's
H
one
plus
more, yeah.
to make it neutral.
But this is H2.
This is HSO4
Yeah.
minus.
Oh, sorry, there's no 2 in it.
This one has it to the best answer.
Yeah, okay. H2SO4 is 2 atoms of H plus. Yeah. So that's 2, not 4.
Yeah, but he means like the
Yeah,
question
but your
stands
question
there was a
is 2 H2SO4,
Yeah.
not H2SO4.
I know. And that's, we clearly understand that's wrong.
Okay.
Yeah, I'm trying to fix it.
So imagine there's no 2.
Yeah,
Imagine there's no 2.
the 2 is wrong.
2 beside the brackets.
It's not 2 H2SO4.
It's
H2SO4.
It's two hydrogen
No, it's not.
Yes,
the
it's 2
question-
hydrogen ions.
Yeah.
Yes, so it's 2 times 0.1.
But he removed the 2. The 2 is wrong, so he will remove it.
No, if it's 2,
Yeah, they
The 2
removed
is gone.
0.1.
I'm removing the 2. There is no 2.
How about this?
Well, you said
0.1, yeah,
0.1.
0.1 times 2 only, not 4.
Yeah.
but
Sure,
answer
what-
pH is 0.6.
Yeah.
So it's minus log 0.1 divided by 2.
Yeah.
So it's
Continuing. Right, what else do we need to see then? That was the log question? That was a good log question.
Yeah.
Yeah. What else do we need to see?
Continue the CDE.
Continue?
Yeah, why not?
If the pH level of HCl is 0.6, what is...
Wait. If you continue, you'll have time to solve my question.
Let's continue with this. If the pH level is 0.06, what's the concentration then? So here the pH level is 0.06, so that means minus log base 10, the concentration, which is what we want, is 0.06. So that means log base 10 x equals minus 0.06. 10 to the power of minus 0.06 equals x. Can someone give me the x, please?
0.87.
0.87 is the concentration. Moles per litre. Molars, isn't that what it's called? Molarity. That's close. Next now, if the pH level is 0.06, then what's the concentration? Oh, we're back to the 2 business again. Sorry, can I scroll down? Yeah. I'm kind of tempted now just to delete the question.
It's right, but you write was divided.
I know I wrote the question wrong. Right, the pH level of H2SO4 is 0.06. What's the concentration? So this is minus log base 10 2x. Yes, okay, equals 0.06. So minus log base plus 2x equals minus 0.06. 10 power minus 0.06 equals 2x. So x is 10 power minus 0.06 over 2. 0.43 molarity. Right. E. If apple juice has a pH level of 3.5, then how many moles of positive hydrogen ions are there in 200 milliliters of apple juice? So, now, we know that the pH level is 3.5. That means minus log base 10x equals 3.5. So that means x equals 10 power minus 3.5, which is, please? Well, here I have, here, 10 power minus 3.5. Small number. Is that right? Very small, 0.000316. Whoa, what the heck?
Change the brochure.
Yeah. 0.000316. Okay? That's the pH level. Sorry, that's the concentration. So that means per litre, there's 0.000316 moles per litre. How many litres do I have in the question? 0.2.
Yeah, 200 milliliters.
Yeah, but that's what I asked. If I asked for how many millilitres, the answer would be 200. If I asked for how many litres, the answer is 1/5 of a litre. So, if it's this many per litre, then it's this many per 1/5 of a litre. In other words, per 200 millilitres. So if I take this answer and divide it by 5, that's how many moles of H plus I have. 0.0000632 moles. And then the last part is Ka, whatever Ka is, I don't remember, is defined as H plus over acid squared. What is the pH in terms of Ka and acid squared? Why did I think?
Times acid squared.
Why did I think of these questions? Ka is equal to H plus over acid concentration squared. Oh yeah, so you have pH equals minus log base 10 H plus. So that's minus pH equals log base 10 H plus. So H plus is 10 power minus pH. So this is 10 power minus pH. What is the value of pH? So I have to rearrange this to get out pH. So that's Ka acid squared equals 10 power minus pH. If I put in a log base 10, I can cancel that. And then if I divide by minus, I get that. So pH is minus log base 10 Ka times acid concentration squared. Mistake? It's right? Right, so it's just part B that's screwed up. I have to retype part B to make it clear. I'm trying to say the concentration of H plus in the H2SO4 is twice the previous concentration. Yeah. Okay.